Comprehensive report, the impact of a Category 5 hurricane hitting a major U.S. city. Executive summary. A Category 5 hurricane, characterized by sustained winds exceeding 157 miles per hour, represents the most severe classification on the Saffir-Simpson hurricane wind scale. When such a storm strikes a major U.S. city, the consequences are catastrophic, affecting human lives, infrastructure, economies, and ecosystems. This report explores the potential impacts of a hypothetical Category 5 hurricane hitting a major U.S. city, such as Tampa, Florida, drawing on historical examples like Hurricanes Milton, 2024, Michael, 2018, Andrew 1992, Camille, 1969, and the 1935 Labor Day hurricane. It examines the meteorological dynamics, socioeconomic consequences, preparation strategies, and recovery challenges, incorporating recent data and expert insights to provide a lucrative and engaging analysis for stakeholders, policymakers, and the public. 1. Introduction. Hurricanes are among the most destructive natural phenomena, with Category 5 storms being exceptionally rare and devastating. Since 1924, only 42 Atlantic tropical cyclones have reached Category 5 intensity, with just 4 making landfall in the U.S. at that strength: the 1935 Labor Day hurricane, Hurricane Camille, 1969, Hurricane Andrew 1992, and Hurricane Michael, 2018. A hypothetical Category 5 hurricane striking a densely populated urban center like Tampa, with its 3 million metropolitan residents and vulnerable topography, would amplify these impacts. This report outlines the potential effects, preparation measures, and recovery strategies, using historical precedents and recent meteorological data to inform its projections. 2. Meteorological dynamics of a Category 5 hurricane. 2.1 Definition and characteristics. A Category 5 hurricane is defined by sustained wind speeds of 157 miles per hour or higher, capable of causing catastrophic damage, including the destruction of framed homes, prolonged power outages, and widespread uninhabitability for weeks or months. These storms often feature low barometric pressure, for example, Hurricane Milton's 897 millibars in 2024, intensifying their destructive potential. Key hazards include storm surge, life-threatening inundation from rising coastal waters, often exceeding 10 to 15 feet in major storms. High winds, sustained winds and gusts, for example, Milton's 180 miles per hour winds, that demolish structures and scatter debris. Heavy rainfall, up to 15 inches or more, leading to flash flooding and landslides. Tornadoes, embedded within the storm, increasing localized destruction. 2.2 Rapid intensification. Rapid intensification, defined as a wind speed increase of at least 35 miles per hour within 24 hours, is a hallmark of recent Category 5 hurricanes. For instance, Hurricane Milton escalated from 80 miles per hour to 175 miles per hour in just 24 hours in October 2024, driven by warm Gulf of Mexico waters, 86 degrees Fahrenheit, and low wind shear. Climate change exacerbates this by warming ocean surfaces, providing more energy for storms. A 2023 study noted an increase in rapid intensification events over the past 4 decades, linked to human-induced climate change. 2.3 Hypothetical scenario, Tampa, Florida. Tampa, a major U.S. city, is particularly vulnerable due to its shallow coastal waters, funnel-like bay, and dense population. A Category 5 hurricane striking Tampa could produce a storm surge of 10 to 15 feet, as forecasted for Milton, flooding low-lying areas like Pinellas County and downtown Tampa. The city's last direct hit was in 1921, making a 2025 strike a historic event with unprecedented impacts given modern development. 3. Historical case studies. 3.1 Hurricane Milton, 2024. Hurricane Milton, which reached Category 5 status with 180 miles per hour winds, threatened Tampa before making landfall near Sarasota as a Category 3 storm on October 9, 2024. Its rapid intensification, fueled by record warm Gulf waters, led to widespread evacuations of 500,000 residents in Pinellas County, and warnings of a once-in-a-century storm surge. Impacts included: storm surge, forecasts predicted 10 to 15 feet in Tampa Bay, with potential for 15 to 20 feet south of the landfall point. Economic damage, potential costs rivaling Hurricane Andrew's $30 billion, 1992. Evacuations, mandatory orders for coastal zones, with 17% of Florida's gas stations out of fuel due to mass exodus. Milton's threat highlighted Tampa's vulnerability, with experts warning of catastrophic losses if it had struck directly as a Category 5. 3.2 Hurricane Michael, 2018. Hurricane Michael struck the Florida Panhandle as a Category 5 storm with 160 miles per hour winds, causing $25.1 billion in damages and 74 deaths. It devastated Mexico Beach, destroying 3,374 homes and leaving areas uninhabitable for months. The storm's rapid intensification near landfall caught residents off guard, underscoring forecasting challenges. 3.3 Hurricane Andrew, 1992. Hurricane Andrew hit southern Florida with 165 miles per hour winds, causing $30 billion in damages and 40 deaths. It obliterated 49,000 homes in Miami-Dade County, with 99% of mobile homes in Homestead destroyed. Andrew's compact size amplified its wind-driven destruction, offering lessons for urban preparedness. 3.4 Hurricane Camille, 1969. Camille struck Mississippi with estimated 175 miles per hour winds, producing a 24-foot storm surge and $12 billion in adjusted damages. It killed 259 people and flattened coastal communities, demonstrating the long-term recovery challenges of Category 5 storms. 3.5 Labor Day Hurricane, 1935. The 1935 Labor Day hurricane, with 185 miles per hour winds, was the most intense U.S. landfall, killing 408 people, mostly World War I veterans in the Florida Keys. Its $6 million in damages, $137 million in 2024 dollars, underscored the need for improved coastal monitoring and preparedness. 4. Socioeconomic impacts. 4.1 Human toll. A Category 5 hurricane hitting a major city like Tampa could result in significant loss of life, particularly if evacuation orders are not heeded. Historical storms like Camille and Michael caused dozens to hundreds of deaths, often due to storm surge, drowning 90% of hurricane fatalities worldwide. Vulnerable populations, including the elderly and low-income communities, face higher risks due to limited mobility or resources. 4.2 Infrastructure damage. Residential and commercial structures, most framed homes would be destroyed, with mobile homes and high-rise buildings particularly vulnerable. Power and utilities, prolonged outages, as seen in Michael's aftermath, could last weeks, disrupting daily life and emergency services. Transportation, flooded roads, damaged bridges, and airport closures, for example, Tampa International Airport halted flights during Milton, would hinder evacuations and recovery. 4.3 Economic consequences. The economic impact could exceed $50 billion, factoring in modern urban density and inflation. For comparison, Hurricane Andrew's $30 billion in 1992 would equate to over $60 billion today. Key sectors affected include tourism. Tampa's tourism-driven economy, reliant on beaches and attractions, could face years of recovery. Insurance. only 13% of homes in Milton's path had federal flood insurance, amplifying financial losses. Supply chains, port disruptions and fuel shortages. 17% of Florida gas stations were dry during Milton, would ripple nationally. 4.4 Environmental impact. Coastal ecosystems, such as Tampa Bay's mangroves and wetlands, would face severe damage from storm surge and saltwater intrusion. Hurricane Helene's debris, still uncleared during Milton's approach, worsened environmental hazards by increasing projectile risks. Long-term effects include habitat loss and water contamination, affecting fisheries and biodiversity. 5. Preparation and mitigation strategies. 5.1 Pre-storm preparations. Evacuation orders, mandatory evacuations for low-lying areas, as seen in Pinellas County's 500,000-person order during Milton, are critical. Infrastructure hardening, retrofitting buildings with hurricane-resistant materials and elevating structures in flood-prone areas. Public awareness, campaigns leveraging platforms like YouTube and X to disseminate real-time updates, as demonstrated by Milton's viral storm tracker videos. Debris management, pre-storm debris removal, as emphasized by Governor Ron DeSantis post-Helene, reduces projectile risks. 5.2 Role of technology. Hurricane hunters, NOAA's hurricane hunters provide critical data via dropsondes, improving forecast accuracy for storms like Erin, 2025. Forecast models, high-performing models, like those used for Milton, guide evacuation and resource allocation. Social media, platforms like X amplify warnings, with posts from emergency management agencies reaching millions during Milton's approach. 5.3 Community resilience. Shelters, pet-friendly and special needs shelters, as opened in Pinellas County, accommodate diverse populations. Insurance coverage, expanding flood insurance uptake, given the low 16% coverage rate in Florida, is essential. Local leadership, coordination between state, for example, DeSantis emergency declarations, and federal, for example, Biden's FEMA authorization, levels ensures resource availability. 6. Recovery and long-term challenges. 6.1 Immediate response. Search and rescue, rapid deployment of teams, as seen post-Camille, to address trapped or injured residents. Aid distribution, FEMA's role in providing immediate funds, hindered by misinformation during Helene, must be streamlined. Power restoration, mobilizing out-of-state crews, as done for Milton, to restore electricity. 6.2 Long-term recovery. Rebuilding, reconstruction, as in Homestead post-Andrew, requires years and billions in investment. Mental health, addressing trauma, especially in communities hit by back-to-back storms like Helene and Milton. Policy changes, post-1935 hurricane improvements in monitoring stations highlight the need for adaptive policies. 6.3 Climate change considerations. Warmer oceans and rising sea levels, as noted in Milton's intensification, will increase the frequency of Category 5 storms. Urban planning must prioritize climate-resilient infrastructure, such as elevated roads and flood barriers, to mitigate future risks. 7. Lucrative opportunities. 7.1 Media and content creation. Category 5 hurricanes generate massive online engagement. YouTube videos of Milton's storm trackers and survivor stories garnered millions of views, offering monetization potential for news outlets and creators. Real-time drone footage and live streams can attract sponsorships and ad revenue. 7.2 Disaster recovery industry. Construction, rebuilding efforts post-Michael created thousands of jobs and contracts worth billions. Insurance and risk modeling, Firms like Karen Clark and AMP Co., which ranked Tampa as highly vulnerable, can expand services. Technology, demand for advanced forecasting tools and resilient infrastructure solutions will grow. 7.3 Policy and advocacy. Non-profits and advocacy groups can secure funding to promote climate resilience and equitable recovery, leveraging public attention post-disaster. 8. Conclusion? A Category 5 hurricane striking a major U.S. city like Tampa would unleash unprecedented destruction, with storm surges, high winds, and flooding causing billions in damages and significant loss of life. Historical precedents like Milton, Michael, Andrew, and Camille underscore the urgency of robust preparation, from evacuations to infrastructure hardening. While the human and economic toll would be immense, opportunities in media, recovery industries, and policy reform offer pathways to mitigate and capitalize on such events. By learning from past storms and addressing climate-driven intensification, cities can enhance resilience and reduce future vulnerabilities. 9. Recommendations. Enhance early warning systems, invest in NOAA's hurricane hunters and real-time social media alerts. Expand insurance coverage, incentivize flood insurance uptake to reduce financial burdens. Strengthen infrastructure, prioritize hurricane-resistant building codes and coastal defenses. Community education, use platforms like YouTube to disseminate preparedness guides. Climate adaptation, integrate sea level rise projections into urban planning.